In 1801, a curious experiment forever changed our understanding of reality. Light behaves as both a wave and a particle until you watch it. Then it seems to choose. What if I told you that simply observing something could alter its very nature? This is the double slit experiment, and it might just be the most baffling mystery in physics. Let's set the scene. Thomas Young's double slit experiment was meant to explore the nature of light. At the time, scientists debated, is light a particle or is it a wave? Young's setup was simple. Light passed through two closely spaced slits, projecting onto a screen. You'd expect two bright lines, right? But no. Instead, an interference pattern appeared, like ripples colliding in a pond, suggesting light waves. But here's what's intriguing. Replace light with electrons, and the pattern persists. Even single electrons create this wave pattern when not observed. Now here's where things start to get strange. Imagine firing electrons, not waves, through the slits one at a time. You'd think they'd create two distinct lines, right? But shockingly, they still form an interference pattern. It's as if each electron goes through both slits simultaneously, interfering with itself. This suggests that particles exist in a state of probability, a cloud of potential outcomes until measured. But wait, it gets weirder. As soon as you place a detector by the slits to observe which path the electron takes, the pattern changes to two clear lines. The act of observation collapses this cloud of possibilities into a single reality. Why does observation change the outcome? This question has puzzled physicists for centuries. It's as though reality only decides what it is the moment we observe it. Some suggest that particles exist in a superposition, a blend of all possible states. Until we measure them, they remain undecided. This idea isn't just mind-bending. It challenges the very notion of objective reality. In a universe governed by quantum mechanics, observation plays a pivotal role in shaping the world. But what is it about observation that changes everything? Consider this. In quantum mechanics, observing isn't just passive. It involves interaction. To measure an electron's path, photons or light particles must interact with it. This interaction seems to force the electron into a defined state. But the question remains, is it the interaction or our conscious observation that causes this collapse? This distinction is crucial, and it dives deep into the philosophical realms of reality and consciousness. Let's explore the implications. If observation alters reality at a quantum level, what does that mean for the macro world we live in? Can our perception influence the physical reality around us? While the effects of quantum mechanics do not directly translate to the large-scale world, the underlying principles raise profound questions about the nature of reality itself. Are we participants in a universe that responds to our consciousness? Or are we simply uncovering the layers of complexity within the quantum realm? But here's where it gets incredibly bizarre. Some interpretations of quantum mechanics suggest parallel worlds may exist, where every possibility plays out. According to the many worlds theory, each time you observe an outcome, the universe splits, creating a separate reality for each possibility. So, watching an electron may not just collapse its wave function. It could be spinning off entire new universes. But why don't we perceive these other worlds? That's the puzzle that keeps physicists awake at night. There are multiple theories trying to explain this quantum conundrum. The Copenhagen interpretation posits that it's the measurement that collapses the quantum state. Then there's the many worlds interpretation, suggesting every observation creates a branching of reality. Pilot wave theory, by contrast, suggests particles are guided by a deterministic wave, no collapse, no alternate realities. Yet none can claim supremacy, as each offers answers and questions in equal measure. Which one is right? That's for you to ponder. The double slit experiment opened a doorway to understanding the very fabric of reality. It challenges our perceptions and reveals a universe much stranger and more complex than we ever imagined. As we peer deeper into the quantum realm, One thing is clear. The universe is full of surprises, and our role within it might be more significant than we know. So, what do you think? Can observation shape reality? Or is reality simply beyond our grasp? Let us know in the comments below. And remember, the deeper you dive, the more mysteries you'll uncover.